Okay, lecture 6. We're going to talk about the union and intersection of sets. So let's see the definition. First, about the intersection of two sets. Remember, what is a set? A set is a group of something, right? A group, anything we can put in a group, and we can call it a set. So intersection of sets means in all the set. If we talk about two sets, let's see, we have an A set, B set, and the intersection we write like this, right? We write A intersect, so this means intersect with B. So A intersection B means all the elements in both set. It's in set A, also in set B. So the notation is this, A intersect B equals to, so this is a set builder notation. Okay. So all the elements, this means X represents any element. So element, then this bar means those guys defined as. Okay, the element in the set A, so this means belongs to. So this letter means belongs to. So X is it belongs to A, and X also and, you see, and. So this is a keyword. And the element is also in B, so in both of them. Let's see this in example. So we have A is this set. Let's graph it, because when we graph, it makes more obvious. So 0 sits in the middle. Towards the right-hand side, positive. Towards the left-hand side, negative. So X less than 2. So first we mark 2. Less than 2, we go to the left. Right? Less than 2, remember, open circle. Go to the left. So all those numbers less than 2. And B is defined all the numbers greater than or equal to -1. Let's say -1 is here. Let me change my color. Let's use red color. So because this has equal sign, this is greater than or equal to, so we make a solid dot. Right, this is a -1. Then greater than, we'll go to the right. So what is in the second? What are those numbers in both, in the intersection? That means in both. You see the numbers from -1 up to 2, including -1, not including 2, right? Those are the intersections. So those numbers from -1 up to 2, including -1, not including 2, are in the intersection of A and B. It's in A, also in B. So it's in the intersection of A and B. So we write it as this. We write it in the interval notation as -1 from -1 up to 2. Jason, hold on a second. So including, we use bracket. Not including, we use 2. Not including with 2, so we use close parentheses. Including -1s, we use bracket. Okay, that's one example. Now let's see. Question 1. Find the intersections of the following sets. And we want to express in interval notation, right? So this is the interval notation. This is a set builder notation. Let's see A. So A is all the numbers less than 4. So let's graph it, because the graphing makes obvious. We always mark 0. And what numbers we need? We need a 4 and -2. So let's see, 4 is here, 2, right? So this is a 4. -2 is here. Let's graph A. Let's graph A, use blue color. So x is less than 4. So all the numbers less than 4, but not including 4. So make an open circle. We go to the left, right? All those numbers are less than 4. Then B, let's use green color. All the numbers greater than or equal to -2. So including -2, we make a solid dot. Greater than, we go to the right. So what is the intersection of both? Let's use a purple color. We see intersection is from -2, including -2, up to 4, but not including 4, right? This is the intersection. Those numbers in the set A and also in the set B. So we use interval notation, including -2, we use bracket. Not including 4, we use close parenthesis. So this is interval notation. Let's see B. We graph again. So we need a number 2 and number -1. 0 sits in the middle. Maybe this is a 2, and this much will be 1. So let's say this is -1. So let's graph A. Right? A is all the numbers greater than or equal to 2. With the equal sign, we make a solid dot. Right? Greater than, we go to the right. So that's A. B, let's use red color. Right? B is x less than or equal to -1. All the numbers less than or equal to -1. So make a solid dot again because we have equal sign. Less than, we go to the left. Do they have intersection? No, because we see from -1 to 2, this is empty. So those numbers doesn't belong to A, doesn't belong to B. And A goes from 2 to positive infinity. And B goes from -1 to negative infinity, right? This is negative infinity. This is positive infinity. So those two have no intersection. So what do we write? We could write, so mathematically use this a little bit like a circle, then slash through. This means empty set, right? You just make a little circle, you slash through. Empty set. So there's no intersection of those two sets. Let's see C. So negative infinity up to 2. Let's just graph here. So let's see, this is a 0. This is a 2. From negative infinity up to 2. Remember negative infinity is negative infinity on the left-hand side. Negative infinity on the left-hand side. So from negative infinity up to 2, not including 2. You see this bracket? Right? Including 2, so we'll make a solid dot. But from negative infinity, so we'll make an arrow go this way. Okay. This means from negative infinity up to 2, including 2. The other one, let's use green color. From negative infinity up to 0. So not including 0 because this is a closed parenthesis. So make a circle, not including 0. Also goes from negative infinity. Right? This also go down to negative infinity. So do you see the intersection? The intersection is from negative infinity up to 0, but not including 0. All those, right? All those numbers are in both sides. So write this one equals to negative infinity. For infinity, we will always use open parentheses and close parentheses, all right? Because infinity is not idea. It's not a definite number. So from negative infinity up to 0, but not including 0. We use close parentheses. right? You see from 0 to 2, that only belongs to the first one, but doesn't belong to the second one. So looking for the intersection, we're looking for all the numbers belong to both. All right, so that's from negative infinity up to 0. Well, let's see D. Draw the line. So we need a -2 and -5. So let's see, 0 is here. -2 is here. -5 is here. So let's graph the first one, negative infinity, positive infinity, negative infinity up to -2, not including -2. You see this bracket, including, we make a solid dot. From negative infinity, so we'll go to the negative infinity. That's the first one. Second one, from -5, including -5 up to positive infinity. So make a solid dot because -5 is in the set, make a solid, then goes to positive infinity. Well, the intersection is obvious, right? Just from -5 up to -2. And including -5, use a bracket. And including -2, also use bracket. That's it. So draw the number line or mark on the number line, make it obvious. Now let's see unit, the idea of unit. So intersection is and, union is or. Okay, we have two sets. We have set A, we have set B. A union B, this notation looks like a letter U, right? U. A union B is a set in either in A or in B, as long as in one of them. That's it. So A union B is X in A or X in B. So compare with A intersect B. That means X in A and, so those are two keywords, X in B. So intersection is and. So the in both. Union is just in one of it, as long as you in one of it, so because it's or. Let's see this example. Let's graph it. So we need 2 and -1. So 0 here, 2 here, -1 here. A is X, all the numbers greater than or equal to 2, greater than or equal to 2. Right? With the equal sign, make a solid. Greater than, go to positive infinity. B is X less than -1. -1 is here, right? Not including -1 because no equal sign. Less than goes to negative infinity. But if we talk about intersection, that's A intersect B, that would be empty, right? Because you see, it goes from this one from -1 down to negative infinity. This one from 2 up to positive infinity. There's no intersection of those two sets. So intersection will be empty. But we are looking for union. We're looking for union. So the union is from negative infinity, we always write it from the left to right. You write the small one first, the big one second. So negative infinity up to -1, not including -1. Union from 2, including 2 up to positive infinity. Okay, so this is unit, this is or. Okay, or. Or means this one, either in this one or in this one. Okay, let's see this practice. So A, of course, we want to use interval notation and graph on number line. So let's graph A. Right, always remember positive infinity on the right-hand side, negative infinity on the left-hand side, and 0 sits in the middle. So we need a 4 and -2. So graph 4, graph -2. Now set A sin x less than 4, less than 4. Let me use different colors. Less than 4, not including 4. So make an open circle, less than, we go to -infinity. B is the x greater than or equal to -2. So greater than or equal to -2. Let's use green color. With a bracket, with the equal sign, we make a solid dot. Right? Greater than, we'll go to positive infinity. So what is the union of those two? You see this go to -infinity, that goes to positive infinity, and A intersect B is this middle part. So the union is all real numbers. So A union B is all real numbers. How do we represent all real numbers in interval notation? To open parentheses, -infinity, up to positive infinity. So this is the interval notation to me, all real numbers. All the numbers on this number line. Well, let's just practice on finding A intersect with B. That means those ones in both. So A intersect is here, right? From -2 up to 4. Including -2, but not including 4. So that's the intersection. Let's see B. Graph number line. We need a number 2 and -1. So 0 is here, 2 is here, -1 is here. Let's graph A greater than or equal to 2, solid dot, because it has equal sign. Greater than goes to positive infinity. B less than or equal to -1. With -1, because of equal sign, solid dot, less than goes to -infinity. So A union B. So we want to find A union B. So obviously, this is the green part, -infinity up to -1, bracket, union 2, bracket, up to positive infinity. Right, that's a union. If just for practice, let's do intersect. A intersect with B. Empty set, right? Nothing in the middle of, nothing, those numbers, nothing in both of them. Okay, let's see C. We need 2 and 0. So let's see, 0 is here, 2 is here. The first set is from -infinity up to 2, solid. Right, from -infinity up to 2. The second one from -infinity up to 0, not including 0, open circle, also goes to -infinity. For union, we see A union B is from -infinity up to 2, right? And including 2. Union. Now, just for practice, again, let's find A intersect B. We did it earlier, but let's do it again, just as a comparison. A intersection, do we see the intersection? This intersection is this way. Also from -infinity, but up to 0, not including 0. All right, last one, D. We need -2 and -5. So let's see, this is 0. This is a -2. This is a -5. -infinity is here, up to -2, including -2, solid. -5 up to -5, including -5, solid, up to positive infinity. What is a uni? We're looking for uni. Do you see the uni is all real numbers, right? From negative infinity up to positive infinity. Because positive infinity on the right-hand side. What about intersection? If we talk about intersection of those two, that would be from -5 up to -2. Okay, so this is about intersection of two sets and the union of two sets.